If you look at the sky at night, Saturn isn't just another shining dot. It's the most beautiful masterpiece in our solar system. It is the second largest planet after Jupiter. But what truly makes it stand out and look like royalty are those rings. These rings aren't a single solid piece. They are millions of chunks of ice and rock orbiting in strange harmony, looking like a diamond-studded crown. Saturn is a gas giant, meaning there is no solid ground to stand on. In fact, if you had a giant bathtub and dropped Saturn in it, it would actually float because its density is so low. It looks calm from a distance, but inside, it hides crazy storms and winds, all while being guarded by over 140 moons. On its long journey around the Sun, the Cassini orbiter was one of the largest and most complex spacecraft ever built. It featured a towering, massive structure equipped with a giant high-gain antenna. Our story begins on October the 15th, 1997. The roar of engines breaks the silence of Florida as the Cassini-Huygens spacecraft embarks on a one-way journey, traveling 3.5 billion kilometers into the depths of space. As it pierces the atmosphere, the first stage of separation begins. The rocket boosters fall away, leaving Cassini alone to face the black void, ready for its long dance with the planets to gain the necessary momentum. After 7 years of sailing through the silence of the vacuum, and after traveling over 2.2 billion kilometers in a straight path, we finally arrive at the Lord of the Rings. But the journey wasn't easy. The actual winding path taken to gain speed from other planets' gravity exceeded 3.5 billion kilometers, an imaginary distance, just to stand before this majestic beauty. We are now in the presence of the planet that has mesmerized scientists for centuries. The time of waiting is over. The era of discovery has begun. The story began in 1610 when Galileo Galilei first observed Saturn. Confused by his primitive telescope, he described the rings as ears or handles. It wasn't until 1655 that Christian Huygens proposed they were a flat, unattached ring. Later, Jean-Dominique Cassini discovered the massive gap now known as the Cassini division, proving the rings weren't a single solid sheet. The rings are 99.9% pure water ice, with traces of rocky material and organic compounds. They are divided into 7 main groups. A, B, and C are the brightest, while D, E, F, and G are fainter. Despite their 280,000 kilometer span, they are razor thin, averaging only 10 to 30 meters in thickness. Their stability is maintained by shepherd moons, like Prometheus and Pandora, which use gravity to keep the ring particles in place. The Cassini spacecraft revealed that the rings are much younger than the planet, likely formed only 10 to 100 million years ago, during the era of dinosaurs on Earth. However, the rings are dying. Gravity is pulling the ice particles into Saturn's atmosphere, a phenomenon called ring rain. Estimates suggest the rings could completely vanish within 100 million years, leaving Saturn as a bare gas giant once again. Inside the outer ring lies the ink gap, a 325-kilometer wide path. Unlike the Cassini division, this gap is kept open by a tiny moon living inside it called Pan. As Pan orbits within the gap, it creates wake peaks, waves in the ring material that can rise several kilometers above the ring plane. Watching Pan interact with the rings is like watching a ship create waves in a frozen icy ocean. Every 15 years, during Saturn's equinox, the sun hits the ring's edge on. This causes the rings to virtually disappear from our view and cast massive shadows onto the planet. During this brief window, the shadows of mountains of ice within the rings stretch for thousands of miles, revealing the 3D topography of a system we usually see as perfectly flat. We now know that the rings are a transient feature. Every second, Saturn consumes between 400 and 2,800 kilograms of ring mass. At this rate, the innermost rings will be gone in 100 million years, and the entire system could vanish in 300 million years. We are witnessing the final acts of a cosmic masterpiece that won't exist for future inhabitants of the solar system. The rings are a violent place. High-resolution images from Cassini showed clumps of ice constantly forming and breaking apart. Some of these fragments, nicknamed snowmen, are temporary structures where gravity tries to pull ice together to form a new moon, only for Saturn's tidal forces to rip them back into dust. This is a constant cycle of creation and destruction happening in real time. Saturn's rings are a complex laboratory of orbital mechanics. From the shepherd moons to the ring rain, every detail tells the story of a system in constant flux. Understanding them is our key to understanding how planetary systems, and perhaps even galaxies, are born and eventually fade away. Deep within Saturn's atmosphere, storms of unimaginable scale brew. Every 20 to 30 years, a monster hurricane erupts, stretching thousands of miles until it circles the entire planet. The storm captured by the Cassini spacecraft was so immense that it spanned the distance of North America from north to south, remaining active for months and fundamentally reshaping the weather patterns of this gas giant. While the storm may appear cold on the surface, infrared cameras revealed a stunning secret. Scientists discovered two glowing hotspots within Saturn's storm. These beacons were 150 degrees hotter than their surroundings, revealing a massive surge of energy and heat rising from deep within the atmosphere. One of Cassini's greatest discoveries was on the tiny moon Enceladus. Its surface is covered in pure ice, reflecting most sunlight and causing temperatures to plunge to minus 200 degrees Celsius. But the surprise lies at its south pole, where thermal cameras detected warm fractures venting salty water from an internal ocean, suggesting powerful heat sources beneath the ice that could potentially harbor life. The spacecraft detected massive plumes of water vapor and ice jetting out from cracks in the South Pole, leading scientists to believe this ocean might contain the essential ingredients for life. Behind the beauty of Saturn's rings lies an invisible beast, the magnetosphere. This interaction creates an intense radiation environment. Nearby moons, like Mimas, find themselves on the front lines, facing constant bombardment from high-speed electrons. This radiation alters the ice chemistry on the moon's surface, explaining the strange thermal maps captured by the Cassini spacecraft. Are we alone? This question haunts NASA scientists. The search for life isn't limited to planets. Our eyes are now fixed on distant moons. Our destination is Titan, Saturn's largest moon, a mysterious, cold world, full of secrets waiting to be uncovered. Titan is the only place besides Earth with liquid seas and valleys on its surface. But the catch is, it's not water. It's liquid methane at temperatures far below freezing. Earthly cells need water to survive, and their membranes wouldn't last in methane. That's why we had to search for an alternative chemistry that could adapt to this harsh environment. Through advanced computer simulations, scientists modeled a hypothetical cell membrane called an azotosome, asking, what substance could actually build this? The answer was acrylonitrile, a complex chemical with the ability to assemble into strong, flexible membranes even in freezing liquid methane. This molecule, C3H3N, is the true hero. Its hydrogen, carbon, and nitrogen atoms are arranged uniquely. Acrylonitrile isn't just a substance. It's the cornerstone that could build life in a world unrelated to Earth, forming the basis for very stable cell membranes. The breakthrough came when NASA, using the giant ALMA observatory in Chile, detected massive amounts of this substance in Titan's atmosphere. The data revealed a very clear, spectral fingerprint, confirming the presence of massive amounts of acrylonitrile in Titan's upper atmosphere, with concentrations reaching 1.9 parts per billion, a number capable of completely changing our calculations. Since Titan has a weather cycle with rain, these materials fall and collect in the seas, opening the possibility of microbial life swimming in the depths of the methane. Every discovery like this brings us one step closer to understanding how life might take forms we haven't yet imagined. Titan isn't just a moon. It's a natural laboratory for life's possibilities. After 13 years of unparalleled exploration, the Cassini spacecraft prepared for its final chapter. It was a bold leap into the unknown. No spacecraft had ever dared to enter the region between Saturn and its rings. In these final orbits, Cassini gathered unprecedented scientific data, mapping with precision that was never before possible. On September 15, 2017, during its final orbit, Cassini deliberately plunged into Saturn's atmosphere, becoming a part of the planet it spent so long exploring. As the journey ended, Cassini dissolved into the storms, marking the conclusion of the greatest exploration story humanity has ever told at Saturn.